Hey guys, what's going on? We got another video today. This one we're going to be talking about energy pyramids. If you remember from a previous video, we talked about food webs and food chains, and we really showed the direction of energy flow in an ecosystem. But today we're talking about the amount of energy that gets transferred from trophic levels to trophic levels, right? So let's get after it. All right, so an energy pyramid is just like I said, it shows the amount, not the direction necessarily, but it shows the amount of energy that gets transferred from trophic level to the next in an ecosystem. So let's write that down. An energy pyramid shows the amount of, so amount guys, amount, not direction necessarily, but amount is more important in an energy pyramid. Amount of energy transferred between trophic levels in an ecosystem. All right? So it shows the amount of energy transferred between trophic levels in an ecosystem. The crazy thing to think about this, guys, is that energy transfer in an ecosystem is really inefficient. Not all the energy makes it from one energy level or one trophic level to the next trophic level. Actually, only about 10% makes it to the next level. That's wild. Why is it so inefficient? Why is only 10% transferred? I'll tell you why. All right, the main reason is because, well, there's a handful of reasons. One reason is not every single organism in one trophic level gets eaten by the organisms in the next one, right? So they may have a lot of energy, but not all the energy is going to be, that's one reason. Another reason is not everything's digestible. So even when you eat something, not all that energy is going to be digestible, and it's going to be lost in your feces and your poop, all that kind of stuff, right? But then also, the biggest thing is really 90% of the energy that is transferred gets used or lost as heat. Right? It gets used by the next trophic level. They need to eat, they need to move, they need to breathe, they're respiring, they're doing all these things. So they're actually using a lot of that energy so it doesn't get transferred. All right? So the 10% rule is what I just talked about. Only 10% of energy gets transferred from one trophic level to the next trophic level. It's really inefficient. All right, so let's write that down. 10% rule says about, so roughly, about 10% of energy from one trophic level is transferred to the next level. Right? Only 10%, right? We talked about it. Not every animal is eaten. So you can't digest everything. And then 90%, let's write this down, it's a big one, 90% of that energy is actually used. That's because about, so again, roughly, about 90% of energy is released as heat. Released as heat from life processes. All right? 90% is lost as heat, guys. Lost as heat. So I don't know. I remember I grew up, I played like soccer when I was younger, and I just remember a soccer practice when I was really young in elementary school. I'd be running around, and then I could feel like heat coming off of my head. Or not, my head felt like it was steaming, right? That's because I'm using so much energy and I'm releasing it. Right? I'm releasing that 90% of that energy from heat, and all organisms do that. And that's why a lot of it's lost, and we only have 10% transfer from one level to the next. So some examples of life processes could include, so I can write EX for example. EX could be, you know, we're breathing, we're respiring, so you use energy to breathe. Use energy to eat. Use energy to move. Right? Use energy for tons of stuff, so you're using it. Right? Not everything's going to make it to the next level because it's being used, being lost as heat. Right? All right, so that's the energy pyramid showing the amount of transfer. But now let's make it visual. What does an energy pyramid really look like? So we're going to go ahead and flip this over. Whoa. And we got an energy pyramid. All right, what you notice here is I have an energy pyramid made of 4 trophic levels. Right? Here's the first trophic level, second, third, and fourth. If you notice, right, it's a pyramid. Why is it a pyramid? Because we just talked about the 10% rule. Only 10% of energy that starts here is going to make it to the second trophic level, and then 10% of that's going to make it to the next one, and 10% of that's going to make it to the next one. So as you move up the energy pyramid, what do we notice? The amount of energy or animals decreases. So as you move up, as you move up an energy pyramid, the amount of energy decreases. That's why it's in the shape of a triangle, right? It's getting smaller at the top because there's less energy, there's less animals, right? There's way more of organisms in the first trophic level. Can you guys remember what organisms do we find in this first trophic level of an energy pyramid? That's right, we find producers or autotrophs, right? So let's fill that in. You're gonna find your producers here. Producers. Why do we find the producers first? Because they do photosynthesis, guys. Yes, they have to take the energy from the light from the sun, right? So we got light energy, kind of starts this whole process off. We got light energy, and this is kind of funny. Only about 1% of the light energy is actually used by producers. That's crazy. Producers have to feed the rest of the food web or the ecosystem, right? And they only get 1% of the energy from the sun, and then 10% of that's transferred. So it's crazy. There's so much energy out there that's not even being used, right? That's wild. All right, so 1% of the sunlight energy is used by producers. And how do they convert that energy into something that animals can use? They do photosynthesis, right? So producers are things like plants, right? And they're doing photosynthesis, which is a phenomenal a phenomenal process that's really let all life exist on Earth, right? Way back in the beginning of time when Earth was first starting, the beginning of Earth's time, photosynthesis started in the ocean, right? It produced oxygen, produced energy that allowed other organisms to evolve. And then eventually plants colonized land. So plants had to go on land first, and then eventually they were doing photosynthesis, creating energy from the sun that allowed animals to crawl out of the ocean and start to live on land as well. So photosynthesis is a huge, huge, huge process for all life on Earth. All right, so trophic level 2, what are we gonna find? We have our producers here. What eats producers? Primary consumers. So we're gonna find our primary consumers in our second trophic level, primary consumers. Primary consumer, right? And if we're talking about primary consumer, we're going to usually talk about herbivores and omnivores. So I'm going to write maybe a rabbit is our primary consumer. Right? Maybe we got a rabbit here. After our primary consumers, we're going to have our secondary consumers. That's right. So up here, not red, black. Secondary consumers. Right? So secondary consumer in this food chain, let's say it's a snake eats this rabbit. We got a snake. And then finally, we're going to have after secondary consumers come our third or tertiary consumers. So we got our tertiary consumers here. Tertiary consumer. Right? And maybe the top of this food web, our apex predator, our top predator today, maybe we've got a hawk. Right? Hawk eats the snake, snake eats the rabbit. Rabbit eats some grass or some plants. All right, so this is what an energy pyramid looks like. But remember, 10% of energy makes it up. So if we're starting with 100% energy here, you can write in red. If we got 100% here, right, that means 10% is going to make it here. So 100% energy in our producers, 10% of energy in our primary consumers, and 10% of 10% is 1%, and then 10% of 1 is 0.1. Right? You're just moving the decimal over. Just moving the decimal over, right? Boop, boop, boop. Right? That's crazy. So let's do a real life example. Let's say that maybe in our primary producers, we've got 20,000 kilocalories of energy. Maybe from the sunlight energy, these plants were able to capture 20,000 kcals. So I'm writing kilocalories, because calorie is a unit of energy. If you read on the nutrition label and it says this food has 100 calories, it's talking about how much energy it has, right? 100 has calories is unit of energy. Kilocalories is like 1,000 times that, right? So we got 20,000 kilocalories. So 10% of 20,000 is going to be what? Just move, the easy way is just to move the decimal over. We're going to have 2,000 kilocalories available for the second trophic level. 10% of 2,000, remember just drop a 0, we're going to have 200 kilocalories. 10% of this is going to be 20, right? 20 kcals. 20 kcals. right? So if you want to do the actual math, remember it's the part divided by the whole if you want to find a percent or the amount of energy, the efficiency of energy transfer from one level to the next. So you do 2,000 divided by 20,000, the part divided by the whole, and you get 10%, right? And multiply it by 100, right? So part divided by the whole multiplied by 100, you get 10%. But what are we forgetting in this food web? We're forgetting these guys, decomposers, right? What trophic level would you find decomposers? Well, technically you can find them in any trophic level because decomposers, remember, how do they get their energy? From breaking down dead material, right? So they're gonna eat or break down any of these things once they kind of die, right? So they can break down the hawk, the snake, the rabbit, and even some grass, right? So technically, these guys can be found in any trophic level, right? And decomposers are super important because they're just recycling that energy and those nutrients in the ecosystem. Remember, energy isn't created or destroyed, it just gets recycled, okay? And then remember, what's getting lost? 90% is getting lost is what? Heat, that's right. So each level, 10% is getting lost because it's being released from life processes as heat, right? That's from eating, breathing, moving, whatever, right? You're using energy and you're releasing it as heat. All right, so pretty crazy. Remember, food web's food chain show the direction of energy flow. An energy pyramid really shows the amount of energy that gets transferred. It's really inefficient, only 10%. Remember the 10% rule. Only 10% gets transferred from one energy level to the next. If you want to do the actual math, remember it's the part divided by the whole. So part divided by the whole multiplied by 100, right? So if we did 2,000 divided by 20,000, times 100, we get 10%. 10%. All right, guys, hope this was helpful. I hope this visual helped you guys out. Remember, work hard, get smart, and I'll see you guys next time.